Hello, Algebra 2. In this video, I'm going to discuss Chapter 6, Section 3, Logarithmic Functions. So, logarithmic function is a way of rewriting exponential function, or I should say a logarithmic equation is a way of rewriting an exponential equation. So here at the top of the notes, you can see I have base b to the exponent of x is equal to a value y. So base b to the exponent of x is equal to a value of y. And you can see example 1 already. So I can also I'm going to just also equate that with something that has numbers. So for instance, 5 to the power of 3 is equal to 125. We know that on our graphing calculators that if, let me clear that, 5 raised to the 3, you get 125. It's 5 times 5 times 5. And that is what we call exponential form. And that's what you're used to seeing. And that's what we've used ever since middle school, probably. Well, a logarithmic form of this equation, or the logarithmic form of this equation, would be log, L-O-G, and then we put the base b, which is what's in blue here, and we put that subscripted after the log, okay, and then whatever the value was that we got goes here, is equal to the exponent. And what this does is this enables us to bring the exponent down to become the value of the equation. So, and then in this example down here, you could see that 5 to the third power equal to 125 would be rewritten as log base 5 of 125 equal to 3. The power, the exponent, is now it's being equal to, and so then log base 5 of 125 is equal to 3. Log, a way to think about log is you could say if you're given this log without it equal to anything, like this, I'm thinking of a different type of problem here. If I would say evaluate log base 5 of 125, and we can see that that's 3, but let's say we didn't know that. One way to think about this would be 5 to what power gives me 125? 5 to what power gives me 125? So log base 5 of 125 is equal to 3. So this example 1 that I've kind of been jumping back and forth to, they want us to rewrite this exponential form into logarithmic form. And as you see here, I did that. Base goes subscripted, the value goes into the log, and the exponent is what it's equal to. So here's another one. 4 to the third power is equal to 64. 4 to the third power is equal to 64. So the base here is 4, the exponent is 3, and it's equal to 64. If we're going to rewrite that in logarithmic form, it would be log base 4 of 64 is equal to 3. Log base 4 of 64 is equal to 3. Again, we're taking the superscripted exponent and we're making it a value. And that makes it easier to solve for that value. Right now, powers are hard to solve for before logarithms come along. So if I gave you the problem 4 to the x is equal to 64, really the only way to solve that before logarithms is to know, oh, okay, 4 to what power is 64? And you have to go through, okay, 4 to the second, that's 16. 4 to the fourth, that's 265. And then you just kind of have to figure it out, kind of like guessing and checking. Actually, it is guessing and checking. Well, logarithms allow us to give us the ability to find exponents. It gives us the ability to find exponents and to solve for them, because now the exponent is the value. And when it's the value, when it's equal to that, then you can enter it into computers. You can enter it into calculators and stuff like that. I don't know. Hopefully that makes sense why we need logarithms. So, yes, log base of a number, log base a number of a number is equal to the exponent. So, Alright, so example 1 was taking exponential form and writing it in logarithmic form. Example 2 is going to be the opposite. It's going to be giving you an equation in logarithmic form and ask you to write it in exponential form. So, for instance, log base 3 of 81 is equal to 4. In exponential form, this would be the base is 3, the power is 4, and it's equal to 81. So this is logarithmic form, this is exponential form. And we're just rewriting here. This is all this is. This isn't the type of problem where we're solving or evaluating or simplifying mathematics. Most of the time, like, there's two types of problems. You're solving or you're simplifying. Well, I shouldn't say there's only those types of, there's a lot of other different types of problems, but like 90% of the time, those are the two types of problems you get, solving or simplifying. Well, this is the other 10% or whatever percent, where we're just rewriting. We're just taking this and we're rewriting the expression in a different form. Or the equation. This is not an expression, this is an equation because there's an equal sign. So, log base 2 of 128 is equal to 7. And that is how you say it, by the way. Log base 2 of 128 is equal to 7. So this is the base 2. It's going to be taken to the 7th power, and that is equal to 128. That's a 7. And by the way, this should be true. I mean, I'm not going to give a problem that's not true. So as you can see, that's equal. I'm not going to give you an equation here that's not a true statement. Okay. So the graphing calculators have advanced a little over the years, this TI-83s, and depending on the type of calculator you have. If you have a TI-84 plus or higher, or more recent, then you actually have a function under the math key, and if you scroll the whole way down, oh, went too far, so you can actually scroll up to go, instead of scrolling the whole way down, you can scroll up to get to the bottom here. There's a log and then a capital base. Entering that in gives you the log, and then it has two blanks that you need to fill in. So for instance, 2 and 128. And then it'll give you 7. Unfortunately, some of the other older calculators might not have that. This list doesn't go down that far. But on your calculator, there is a key called log right here. And there's no base listed for that log. Well, a log with no base listed is by default base 10. Okay, a log with no base listed is by default base 10. Okay, that's important to note because you can solve logs base 10 with that key on the face of the graphing calculator. There's actually a property in logarithms that we're not to yet that makes it pretty easy to do this up here with log base 10s. I'm just not ready to explain that yet, but I'm telling you about this key here, this log base 10 key, which actually, if you forget that that is base 10, you can see in blue above it. In my graphing calculator, it's blue, but it might be a different color depending on your style of graphing calculator. It has 10 to the x power. Well, that key, so if I did second 10 to the x, that is the opposite of log base 10. Okay, so that can remind you that this is a log base 10 key with that little 10 there. That's because these two things are opposite. So log base 10. Okay, so jumping to this, I'm going to use that in a second, but let's jump to this example. Solve for x. 10 to the x is equal to 85. Well, before logarithms, we wouldn't have been able to solve this type of problem. Sorry, it's moving. Okay, there we go. Alright, we wouldn't really be able to solve this type of problem before logarithms. You cannot divide both sides by 10. That's not what this is. It's not at 10 times x. This is 10 to what power of is equal to 85. So we don't have an operation. You can't take the x root. Taking the x root doesn't solve anything. You still have an x. It doesn't get rid of the x. It just moves it over here and makes things even more complicated. So this is why logarithms are important, because now we can convert this to logarithmic form, and that enables us to solve it. And in fact, just converting this to logarithmic form solves the um, the problem, because we had isolated x with this. Like, that's our goal when we solve equations, is to isolate the x. And so we divide both sides when there's multiplication in the problem. You subtract when there's addition, right? If there's a square, you take the square root. You do these things that are opposite what's given in order to get x isolated. That's the goal. Get x by itself. Well, logarithms enable us to do that when our unknown is in the exponent. And 10 to the power of x equal to 85 would convert to the logarithmic function equation log base 10 of 85 is equal to x. And you can see x is equal to log base 10 of 85. Now, going back to the graphing calculator, we can use the log key on the graphing calculator to actually evaluate the decimal value of this. And I know it's going to be a decimal value because 10 to the first power would be 10. 10 to the second power is 100. Well, there's 1 and 2. Both the integer answers 1 and 2. And it's neither of those. So it has to be something between 1 and 2. And there's only decimal values between 1 and 2. So on the calculator, we're going to press the log button. And we're going to put 85 in. Log 85. That's log base 10 of 85. And we get 1.9. And it actually makes sense that it's closer to 2 than 1, since 85 is closer to 100 than 10. So 1.929. Longer value, but we can go 2 decimal places apparently. That's what I did. 1.93. All right, so that is the first part of section 3 of chapter 6. And there's going to be a second part, but there is homework based on this first part. And I will list, so this is a screenshot of the problems, 12 to 34 even. So not all of these problems, but I will actually, rather than you needing to pause this to look at this, which you're welcome to do if you want, but I will post these problems on Google Classroom. So, logarithms introduction finished. Thank you and good day.